Hi there, crew, and welcome. It is March 31st. I'm Geology Professor Shawn Willsey, back in the office, back in the USA after an exciting, awesome, exhausting whirlwind trip in Europe and in New York City. Happy to be back with you, providing another update on our eruption that's going on in Iceland. It is about 9 a.m. Mountain Daylight Time, 3 p.m. in Iceland. Thanks for joining me. What I'd like to do is provide a little bit of an update. Again, I feel like getting back in the game, I'm doing these as much for myself as I am for you, the viewer. Just trying to wrap my head around some of the data. Obviously, didn't see everything that was happening over the last 10 or 11 days while I was gone. But I think doing the updates is helpful to me because it helps me process everything and just understand the situation a little bit better. So I want to thank Amanda Joe, as always, for providing a lot of the information and keeping me up to date each day. I was getting messages and emails from her with nice, tidy packages of information so I could be kept up to speed as best I could while I was away. Looking forward, I'm back to classes this week, and I have an incredibly busy April and May with field trips, with classes winding down in the semester, just all sorts of good stuff. But it's all self imposed. I'm not complaining. I'm looking forward to it. But things will be moving pretty quickly. And so I will try to keep providing these updates and other information to you as best I can. I know there's people interested in me covering other events and other things in the world. Just don't know if I have the bandwidth, time, and or energy for those at this moment. So I'm gonna stick with Iceland, keeping an eye on Hawaii and Kilauea like I always do, and we'll see if I'm able to do anything else. But for right now, that's keeping me pretty busy. So the last update I did was, I think, Tuesday. Is that right? Tuesday, the what day was Tuesday? Tuesday the 26th. I did a brief update from Prague over there in Europe. So let's go ahead and get to this update here. What we can see here is a current webcam view from live from Iceland that shows the eruption is still going on. The eruption that began on March 16th is now, we're good 2 weeks into this eruption. And I'll be honest, and I've said this already before, that I was, I think, a little bit naive and complacent when it came to this eruption. We had the December eruption and the January and the February eruptions, and those all behaved quite similarly, where they were fairly short lived. Maybe erupted a large volume of lava initially, but quickly dissipated. So I thought that might hold true again in for this March eruption, but I was wrong. We're now looking at week 2. It is still erupting. The activity has dropped considerably from what it was 2 weeks ago, but it is still producing lava at the surface and feeding a lava channel, which we'll get to here in a few minutes. You can see the camera jumping up and down a little bit. It's quite windy today in Iceland. The winds are out of the northeast, and we'll talk about those and how those are affecting the gas distribution. You can see all this kind of bluish gray sulfuric gases coming out of this vent. So we have basically at this point 3 main vents. You can see the largest one here, which is the northernmost vent. There's a secondary one, a little hard to see through the gas there. You can see a little bit of red popping up right about here. And then the third one is pretty much dead and inactive for the most part, and it's out of the view here off to the right. That's the southernmost vent. This northernmost spatter cone, though, so these vents have been throwing out blobs of lava that have piled up around these individual vents and constructed a cone, what we call a spatter cone. So these spatter cones form as the lava's thrown out. It sticks around the vent and builds up. Now these spatter cones can have, they'll have a limited finite height to them because you have to maintain the gas content in the eruption has to be able to throw that lava up to the rim. And as the rim gets higher, if the lava being ejected can't reach the rim, then that's going to cause your spatter cone to reach its sort of critical height. And it seems like we're getting close there with this one. It might get a little bit higher, but we would really need more gas-rich eruptions to throw lava out onto the rim in order for this thing to get appreciably higher. And it might get a little bit higher. Our estimates are this thing's about 30 meters high, so it's close to 100 feet in height, which is pretty impressive. You can see there's a open section here on the southwest side, and that's where this sort of bubbling up lava that's in the vent here in the crater is sort of pouring out and then flowing to the south. We'll look at another view of that here in a second. But these spatter cones, they're sort of, they both construct topography as they're throwing lava out around the vent, but then they can also collapse in on themselves. And so some of the good folks that have been diligently watching these on the webcams have been able to watch sections or walls collapse in. So while it's throwing lava out onto the rim and building itself up out onto the rim and onto its flanks, it's also, with that very hot molten lava in the interior, thermally eroding and causing gravitational collapses on the inside. And so they do tend to widen over time, these spatter cones, as they develop. And then, like I said, they'll typically reach a critical height. I'm trying to think of like the tallest spatter cone I've ever seen. Yeah, I feel like this one's getting pretty close to at least the tallest one I've seen. It's possible there's ones that are twice as big as this, but you'd be hard pressed to find one much bigger than that. So this may be reaching its final height, if you will. And once it gets, the lava can't be propelled out above the rim. It'll continue to erupt, but it'll just continue to erupt within this confined crater, and then that lava will pour out through the breach in the crater wall here out to the southwest. So let me show you a couple other views here. This is a little closer view of that spatter cone, a little more stable camera view here, and you're able to see right into this crater. You can see the low section, the breach here where the lava actually pours out. This feeds a lava channel. We'll get a good look at this from above here in a bit. But this is the most active vent that we have as of today. And so we'll have to see how many more days this thing stays active. It could persist for some time. At this point, I'm not making any sort of predictions or who knows what's going to happen. I'm not going to, I have no, basis for saying that it's going to keep winding down. It's been going on for 2 weeks now. And as long as the lava supplies continue to be fed from below, it will continue to erupt. And I think there's good reason to suggest that might happen. We'll get to the GPS data in a bit and look at that. So, okay, a couple other things I have for you here. Let me check my notes, making sure I covered all the points here. Yeah, so we talked about this spatter cone and the other one just to the south, forming this lava channel. So a river of lava, if you will, that flows to the south topographically down the slope. There is a gentleman in Iceland, and let me get his name correct. So let me just go to his Instagram page. That might be better. His name is Hurður Krislefsson, and I hope I pronounced that correctly. But he's been sharing some great images both in the news and on Facebook and some other places. And so I wanted to show you a little bit of what he's got here. This is on the Facebook thing. So here is the active vents, and this image is from March 28th. So it's a couple days old, but it's pretty accurate as to what's going on. So this is a view to the north. You can see the Blue Lagoon and the power plant over here. Reykjavik off in the distance, and then the older December and February flows out here to the north. But you can see those active vents erupting here right in the middle of the screen, and then forming this lava channel, this river that's flowing to the south. And as it approaches, let me spin this around now and hopefully not make you sick. So there was a tongue of this lava that flowed off to the east. I don't think that is active anymore. That's pretty much cooled and crystallized, or it's not completely cooled, but it's no longer active. Here's our old shield volcano here. And then if we spin this around and look back to the south, give us a little better view of the town of Grindavik there, the road, and here's that lava flow that came close to impacting the coastal road, but didn't quite make it that far. Here's our defensive berms or barriers that have proved to be quite effective in diverting this flow. And then if I can not make you sick, hopefully, and show you. Okay, so the eruptive vents are just off the view on the bottom here, but the lava channel coming down, you can see a few glows here. Here's the hill Hagafelt. And so that's sort of ponding here. So a lot of this lava is not making it to the distal ends of the flow field. It's sort of just riding up on top of these older flows and sort of spreading out, ponding a little bit, and not progressing down slope very much. Let me try to spin this around. It's a little tricky. Here's a sideways view. That might be a nice view there. There's the vents. There's that lava channel. A little hard to tell because it's during the daytime, but you can see some of these red spots in here. And so it's sort of ponding up in this area. The other interesting thing that happened that I talked about in my last update was that it filled in this quarry, this area that had been used. You can see the road coming into it off of the main road into Grindavik here. And so this was an area where they had been quarrying out some of the probably old pillow lavas, some of the more loose um, basaltic material, and they were using that probably originally for road construction and road base, but then later they were using that as primarily for building up these defensive berms. So it's actually kind of weird irony that, they took rocks out of there and then the volcano just put more stuff right back into that spot. But that's where some of that lava flowed down and filled that low area where that quarry is there. Um, so there's the flow field there, and again, thanks to uh, Hurthur Krislifsen. He has an Instagram page, so there's his Instagram page. He's got a lot of nice photos and images there. So if you're on Instagram, you might want to follow him and check out some of the great photography and video work he does. Just want to give him proper credit for that, and thank you. And we'll look at one more set of images he has here in a little bit. Let's go to the Met Office update, and they do have a new flow field map out that I'll show you here in a second. So they haven't updated anything beyond the 27th, which was about 4 days ago, presumably because things have been pretty constant since then. There's not a lot of new activity to report. And also it's a holiday weekend, and so they probably are a little bit short-staffed. They're keeping an eye on things, but maybe not putting out updates as regularly as they might if it was a weekday or something like that. So this is from 4 days ago. Let's see, anything important here. Activity in the volcano eruption has been pretty constant since Monday. Um, Lava flows in a lava river to the south from the craters, mostly on top of the lava bed that formed during the first days of the eruption. And then they go into this image here that I'll show you here in a second. In fact, let's just go there now. So here is, let me make that smaller. Here is the new flow field map that they have out. So in purple, here's the town of Grindavik down here. They don't have the vents shown, but the vents would be somewhere in this region here, these southernmost vents from the March 16th eruption. There's that older shield volcano, that flow lobe that went off to the east or southeast. And then what they're showing here in the red color is this is area where the lava has expanded the flow field since the initial eruption. So from March 20th to 26th, everything shown in this reddish color here is an area where the lava expanded outward to as it sort of pooled up in this area. This main little lobe here, that's that quarry that the lava flowed into. Down here we have the January 15th lava field, the one close to town that destroyed the 3 houses, and then the other section of it that was right on and in and through the defensive berm there. What's interesting with this is in thinking about how this lava is sort of pooling up here. So think about it. We still have vents erupting at the north end here. And then that lava channel comes down and it's just sort of all sitting here and piling up. And what can sometimes happen, and I'm not making a prediction here, but one thing to be aware of and why this is a dynamic and still risky or dangerous situation where we can't just let folks just park their cars on the road and hike in to watch this thing is as that lava is ponding up on top of these older flows, it's at an elevated position, and you can sometimes get what's called breakout. So you can sometimes get the lava breaking out of that ponded, perched area, and then it starts to flow rapidly downhill, kind of like it did a few days ago when it actually cascaded down into the quarry area. So while that lava remains active coming out of those vents and continues to just sort of stagnate and sit in here, it's building up the topography, and there is the potential that this lava could break out of this topographic region here that's mostly flat or low relief and start pouring out in some other direction. It might head further west and impact the road here. It could flow back down to the south. I kind of doubt that it'll reinvigorate this distal flow lobe here that was headed for the road. But just a lot to consider. Lava flows can move in unpredictable ways. They can build up topography, and they can sort of challenge our conventional thinking when it comes to which direction it's going to go, what path it's going to follow. Starting with the topography is always a good idea, but then it sort of generates and makes its own topography through time, and that's what makes it quite difficult to predict. So here's some images from this gentleman here, Hurther. And so I wanted to show a couple of these because I think they're really, really spectacular. So here's a view looking to the south. And so here's the eruptive vents. There's that biggest spatter cone there, the northernmost one. You can see the second one there. And then the third one, the southernmost one, which by all accounts is in its last few stages, doesn't seem to show a lot, if any, of incandescent glow. So there might be a little bit of lava in there, but it's not erupting and pushing out a lot of lava. It's mainly emanating mostly volcanic gases. This also shows along the margins, especially on this, well, both sides of the flow, on the east and west sides, they've been dealing the last few days with moss fires, so wildfires in the moss. So the heat of the lava will dry out the moss along its margin, and then it can actually ignite, and then the winds can sort of fan those flames. And so they are working on containing these moss wildfires along the margins of this. They also have to keep in mind where this gas is going. So right now, today, the wind's coming out of the northeast, and so the winds would be blowing it sort of past Grindavik and basically between Grindavik and the Blue Lagoon area. So they're probably mainly working on this east side. It would be pretty hazardous to work on the west side today given the wind conditions. But a couple other great photos here. Here's a great photo he took of some of these firefighters dealing with the moss fire. And then this just gives you nice perspective of the height and steepness of this spatter cone here, this 30 meter, maybe a little bit taller, 35 meter tall spatter cone. And again, as long as it can throw, as long as you could see it, with this view here is perfect too. We're sort of looking straight on with the horizon with the rim of the spatter cone. As long as you see red coming over that horizon line, then the spatter cone presumably is able to continue to build upward, because that means it's able to eject lava spatter, if you will, over the rim where it sticks to the edges here. It forms a rock called agglutinate. I've actually done that on a couple of videos. I've showed you what that rock looks like. I think the most recent one might have been the Black Crater video I did in Northern California. I walked around an older spatter cone and showed the rocks up close. So here's a modern example of exactly that process taking place here in Iceland, building up this spatter cone. And very similar to the one we see over at it erupted in 2021 over at the Fagradalsfjall area. There's another very prominent spatter cone that was generated through that eruption. And maybe that's what we're going to see here. That eruption in 2021 went on for about 6 months. It is possible that this eruption through this primary vent here could be sustained that long. We'll just have to wait and see. It's anyone's guess as to when this thing will end or wind down. And I think, now that we're in this sort of new phase, it could persist for some time. So great image from Horther there. Another great image here. This is looking, I guess this is looking west or southwest. There's the power plant there. You can see this spatter cone, and because it throws out these sticky blobs of lava that just stick to the sides, it's able to build up a fairly steep profile here. You'd think with this type of lava, we think of shield volcanoes where they're more low angle, but because this material is ejected out of the vent aerially and sticks to the sides of the volcano, it's able to form a much steeper cone, similar to a cinder cone, but different in terms of what it's ejecting. Cinders are very small, frothy pieces of lava, and this is more larger, irregular blobs of lava that are sticking to the side. So there's that north vent, and then the middle one, and then we can't quite see the south one there that's kind of dying down. A couple more great images from him. That shows all three there. There's the north spatter cone, the primary vent, this middle one. You can see them both feeding this smooth more hot, low viscosity lava flow that's flowing out of both of these breached craters or spatter cones and flowing off to the south. A little bit of the moss wildfire there along the margin, and there's that third cone again that's sort of dying out. Great view there of the actual lava river with some nice contrast, probably in the evening or morning time there. I guess that's evening time, sun setting in the west. So there's that lava river that's pouring down, and then it's just kind of accumulating in this broad area here. It's not feeding these far-reaching ends of the flow field. It's just stacked up on top, so it's building up a high topographic area. But that means that the potential exists that it could spill off that topographic high point that it's created, either to the east or to the west, possibly to the south. And so that's a bit of the hazard game we have to play going forward. Another view of it here. This one's looking to the north or northwest, I suppose. And so so there's those three craters there. The lava river coming down, carrying these big chunks of partially solidified darker crust. So think of these like icebergs on the river. They're just rafted down with the flow. And then they can actually because they're somewhat solidified, they can interact with each other, bump into each other, get torn apart, spread out. Pretty incredible footage there. And then this one's pretty cool here, showing actually some of the spatter being thrown out by the vent. This is probably that big one there. This is that agglutinate material. So this is where the lava spatter falls on the rim and just sticks together. Just think of like throwing wet paper towels at a wall, and they all just sort of accumulate. And so this is what we call agglutinate, kind of a crazy fun word in science. And then you can see some of the wildland firefighters over there in the distance trying to put out some of these moss fires. Another great view there, probably again at sunset, looking to the east this time. Fagradalsfjall is up here, and I think that's actually I'm not quite sure, but that might be the spatter cone right there from the 2021 eruption. And so here we have this new one here that from 2024, and who knows how large this will get. Here's an older crater here. So nice image of just how nature can repeat itself, right? Like here's the evidence from past eruptions, thousands of years ago, 3 or 4 years ago, and then a recent one here. Another view, this is looking up. I think this is looking to the south. So these are some older craters, although those may be from the February eruption. Not sure, but some older craters, and then that big north one there, and then you can see a little bit of the second one there as well. So great images from this gentleman, and just really pretty spectacular. So I thought I'd show some of these just as a nice visual. There's the vents and the lava river coming down to the south. And then he has this nice video of close to the vent, zoomed in, of course, but the lava being ejected, propelled by the gases, and then you can see it just sort of splash and stick. Now, some of it does kind of flow back in, but it's cooling so quickly that it's able to adhere to the rim and stay and stick for the most part, and therefore build up the rim. So the rim gets a little bit higher with each subsequent eruption, and that's how you build these spatter cones. So this 30, maybe 35 meter tall spatter cone has literally been born before our eyes over the past 2 weeks or so. Great video there. Here's another one here of just the flow lobe. So you can see the lava pouring down through this narrow channel. As it starts to slow down and fan out here at the distal end, it starts to back up, and the partially solidified crust starts to form these ropes. So this is a nice classic Pahoehoe lava flow. You can see some of the ropes over here that have solidified from a previous event. But yeah, just really nice behavior of how the lava flow moves, behaves, faster through the constriction, slower here as it fans out and broadens. And then you can see some of the wrinkles or the ropes that form on the surface there. So and then here we have just, I assume he's doing, I don't know if this is like a drone taking a picture of a drone, or I don't know how he's doing this. It's pretty impressive. And of course, it looks much closer than it is. There's probably some foreshortening there and some, optical angle type things. So, okay, I think that was it for those, but those were really, really spectacular. And again, this is the gentleman's name, Horther Krislifsen. Hopefully I got that right. So he's got a lot of followers and does great work. So thanks for making those available to the media as well as myself. News story here about the southernmost crater dying out. And so mainly wanted to put this in here, excuse me, for the picture, but I suppose maybe we saw just as good pictures that we just a few minutes ago, but you can see some of the wildland firefighters down here and then that northern cone. And so it does give you a little bit of sense of how tall it is. And so the height, no one's actually measured it exactly. These are all just estimates. So 30 meters, 20 to 30 to maybe 35 meters is all the numbers I've been hearing from folks that have just tried to make a good ballpark estimate as to how tall this thing is. A little bit of news from Grindavik, and I do have the earthquake and GPS data we'll look at as well. So I kind of have this in a random order, so I apologize. Yeah, basically, I mean, the damage is pretty severe. Amanda Joe told me their house is being sold. They're closing on their new house. They should be moving. They got all their stuff out of Grindavik, but she said the last time they were there was new cracks in the building, in their house, and in the foundation, and so she just doesn't feel safe there anymore. And so, yeah, the future of the town, it'll be tricky. I think the businesses can go on, the harbor and some of those businesses that are there, but the other types of businesses that rely on residents and tourism, those ones are probably in trouble. And then of course there's just the structural damage, right? So then there's just the damage to the infrastructure, the places where it's just not safe to live or even do business there. And so this article here talks a little bit about how, that bad some of the damages and just what some of the options are going forward. Let's turn to the earthquake data. Not much to talk about with earthquakes. I know that on my last update, there had been kind of moving away from the Reykjanes area and looking at Iceland as a whole. There had been some seismic activity and noise around Askja, this caldera system here. I'm educating myself more about this volcano as we speak. I've got a couple papers I want to digest. And so when I do my next update, which by the way will probably be a live stream update, I'm thinking this Tuesday, the 2nd, probably at 2 p.m. Mountain Daylight Time. So that would be 8 p.m. Iceland or UTC time. So I'll put an announcement up for that if you'd like to join us for that. But I'll provide some more information about this volcano, because this volcano may be, although we need to watch all the Iceland volcanoes, this one may be one that keeps us busy and shows some signs of activity moving forward. But over the last few days since my last update, there hasn't been a whole lot of seismic activity here, just a few small earthquakes. Nothing alarming, nothing that shows that it's going to erupt anytime soon, but just some things to be aware of. So let's look at the GPS data. And I think there's an interesting trend here. Let's go to Svartsengi, because I was looking at this before I started recording. And here is the uplift data. So here's, of course, if you're new to this, let me briefly explain. So ground deformation, the movement of the ground up, down, left, right, east, west, north, south, is measured in a couple of different ways. But one of the more reliable ways we've been using in Iceland so far has been just GPS stations on the ground. So whenever the precision on the GPS instruments is good enough that whenever the ground is moving, we can detect that movement. And so the idea is as magma moves into the subsurface, the station will possibly move up if it's sitting on top of the area of uplift caused by that magma intrusion, but it also might be moving away. So think of it like rising, expanding bread dough as you bake bread. And so there's not just the upward motion, but there's outward motion in the other two dimensions as well. So the top graph shows us north-south movement. So anything up above zero is a movement to the north. If it goes down on this graph towards these negative numbers, it's southward movement. So here we are, and this of course is time. So this goes back into January. Here's our January 14th eruptions. You could see there was a dramatic move to the north during that eruption. This one right here is our February 8th eruption. So it actually moved the opposite way just a little bit, moved a little bit south. Then you can see things trending to the north, and then here's our March 16th event here. So the north-south movement can show you a few things. The east-west one is a little bit less, I guess, well, not confusing, but this one's this shows northward movement, a little bit of southward movement, then southward movement again. This one's pretty straightforward, where we have at January 14th we have negative movement here, which would not be east, instead would be the west. So it's movement to the west, then it's not moving at all. Then there's another eruption event, moves to the west, and then you can see these drops here. So that would be January 14th, January 14th, February 8th. Oh, this is the March 2nd intrusion event. Yeah, that really doesn't show up much there. So that's where the magma actually moved in through the subsurface but didn't cause an eruption. And then here's our March 16th eruption event here. And then the last graph shows the up-down motion. So if it moves up on the graph, the red dots, then that would be upward motion, what we correspond with inflation. The magma is inflating, or more magma is moving into the system. If it were to move downward, we would call that deflation, and that would be, again, interpreted as magma leaving the system. So you can see the steady upward movement of this GPS station over time, culminating here with the February 8th eruption, and then here, which March 16th. But here's the trend we want to look at, because every time we had an eruption prior, for the most part, we had an eruption and deflation because magma was leaving the system, and then inflation resumed, and that allowed us to, estimate and hypothesize about when the next eruptive event would be. But now we're at and these were all short-lived eruptions, right, that only lasted a few days, and then inflation resumed. But now we're looking at a situation where the eruption is still ongoing. And so if you look at this trend of data points here since March 16th, there was a slight rise in the points, I think, just barely. Again, there's error bars here, so there's some room for interpretation, but maybe a slight rise if you want to cock your head to the side and squint real hard, for maybe I don't know, 4 or 5 days or so. But then the last cluster of points here, and maybe we'll zoom in on these to look at them a little bit more closely. The last cluster of points seems to be sort of flatlining. And so I think there might have been a little bit of inflation, a tiny bit, possibly, after the March 16th eruption. But that trend's not continuing. Otherwise, we should be, if we take the slope of this little trend of lines here, at least just with an eyeball, right, like best fit kind of thing, we should probably have these dots somewhere up here. But instead, they're down here. They're holding steady, more or less, at where they were 4 or 5 days ago. And so possibly we're reaching a state of equilibrium where the magma that's ascending into this shallow subsurface magma reservoir at about 5 kilometers depth, and the output of lava coming out of those vents that we looked at with the pretty pictures and videos, those two are possibly in equilibrium and more or less at the same rate. So only time will tell. This can easily kick up or down moving forward. But an interesting little trend there in the data. I haven't looked at some of the other stations. Let's check this one here. This is the Blue Lagoon station. Yeah, similar kind of trend, I think, here, where it looks like initially, if you look at the first half of this trend of dots, data points, there's maybe some slight upward trend, a little bit of inflation, but then a little bit of a dip, and then it's come back up. So overall, maybe more of a flattening over here. So again, we'll just have to see moving forward over time how this all plays out. Do we want to look at one more? We could look at this one, the Eldvorp data. Bigger error bars here, so it's a little trickier. Yeah, maybe the same thing. I could talk myself into these, all being at a very slight inflationary trend, or maybe a little bit steeper at the beginning and then more flattening out here. So the GPS data we'll just continue to watch moving forward and see how that looks. Let's see. Oh, the wildfires. So yeah, probably the only ones who want rain for Easter. These are some of the firefighters out there dealing with the moss fires. And so as that moss gets dried out by the heat from the lava flows, and they've had the wind can dry out the moss as well, and then obviously having several days without rain, that makes these moss fires more likely to spread, especially with the wind. And so this is a little article here, and I'll be sure to link most of these to the video description if you want to look at these on your own. But yeah, they got some good experience from last summer around Litlihruter, the eruptive area near the Fagradalsfjall system. And so they've kind of learned what works well for containing these little moss fires and kind of getting them out quicker. So a little article there. And I think that's all I have moving forward. I didn't show any of my Google Earth stuff, so we could maybe come back here. I did add in, so those are the defensive berms. And just as a quick review here, here's the December 18th eruption. Here's the January 14th eruption down here. February 8th was sort of over the top of a lot of the December area. And then here's our March 16th eruption here. I did amend mine a little bit, just kind of with eyeball, so that it would include, let me get rid of these now. Well, we'll leave that one in. No, we'll take it out. So I have it kind of covering the mine there. But this is not perfect. I think, this doesn't have the great details here. I'm not sure if this little island exists anymore. So hopefully, I can't remember who my good loyal viewer is that gives me these KMZ files with these outlines on them. But that would be great if you could get me a new one when you have a chance and can use the Met Office data. Anyway, so yeah, so that's our update for today. I'll do another one. Like I said, I think I want to do a live stream one because it's been a while since I've been able to connect with you folks with my trip over the last couple of weeks. So it's going to be a busy week. Just back to classes tomorrow. I have a talk in Salt Lake City the following Monday that I need to prepare to the Utah Geologic Association. All good stuff though, all self-inflicted fun, not complaining at all. It's just a busy week. But I do want to do a live stream this week, and I think Tuesday will work best. Amanda Joe is good for that time, and we'll see if we can get Lisa and Susan to help out and moderate that as well. But the plan for the live stream will be I want to talk a little bit about, we'll do a quick update if there's anything that's happened here near Grindavik that we need to discuss, we will. If there's any new data that's come in, we'll look at it. But I want to spend some time discussing Askja, so this other volcanic system in central Iceland that sits right about here. And that's where we've been seeing some activity lately. So let's spend some time learning about this other volcano while we keep an eye on this other one. I'll do maybe a few pictures for those that are interested, a brief overview of my trip in Europe. I did manage to do a couple videos, so those will be coming out soon. And then maybe a couple other news and announcements, and then of course we'll get to some viewer question and answers. So hopefully that sounds like a good plan, but I'm happy and excited to be back in the saddle, happy to be here with you, providing these updates on a much more regular basis. Thank you for your patience while I was gone. I know a lot of you wanted to hear my take on things, and it was a whirlwind. We had busy days where it was up early and back late, and just wasn't a lot of time for me to do much there. So thanks for your patience and for sticking with me here. And we will also try to get Gylfi from Just Icelandic. We talked about doing something together. I want to get that scheduled. I have a couple other folks I'm talking to about interviews and getting some other geologists involved with what we do here, so you can get some of their perspective as well. So we'll look forward to doing that. So thanks again for your support as always. I appreciate it very much. Thanks for joining me, and we will see you next time. Hope you can make it to the live stream event this Tuesday, April 2nd at 2 p.m. Mountain Daylight Time, which would be 8 p.m. UTC or Iceland time. Thanks again. Take care, and adios.